at this VAP profile, you will see also the security, and optionally, you could define a traffic profile. In this case, it says traffic profile. This traffic profile, you have to define it previously. I define it here, traffic profile traffic 1. This is very optional, and I put user isolate all. This is a typical situation for the guests wireless LAN, in which you cannot you don't allow to communicate wireless guests between each other. So they are only allowed to communicate to the internet, but not between each other. So you define a user isolate all. In this case, well, this user isolate feature is configured at the traffic profile. So when you will have that traffic profile, you assign it to the VAP profile. Okay. So when you will have the VAP profiles, well, that's a very, very important feature. So I'm going to next to that topic, you can create, for example, the access group, access point groups, and the access point itself. I'm going to show you the because the order in the configuration is not the most logical order. I'm going to advance a little in order to display the configuration in the most logical order. Here is the place when you configure the access points on the controller. For example, the first access point ID 0, AP MAC. This is typical by default, AP MAC, and you put here the MAC address of the access point. For example, this access point is having a MAC address, this MAC address 5E20. This is the last of octets. Okay, so at the access point you will see this MAC address is for that IP address. So when you define the access point at the access controller, you have to define just the name and the MAC address. This is done automatically, the registration of the serial number. So you define here the access point, you define, for example, a name for the access point, you define a group, and then you define, for example, radio 0. Radio 0 is the 2.4 gigahertz band. So you are telling this access point you have to work on channel 1 for the 2.4 gigahertz band, and you will work for the 5 gigahertz band, that is the radio 1 circuit. You will work on channel 64. So with this configuration, you're telling the channels that are working on each access point. Well, all of this in a very static way. You could also define the access controller to work all that automatically. Okay, but if you want to set the access controller to work all automatically, you won't learn a lot of things you could do. So that's why at this example, I am working with this in a static way. I am defining which channel each access point has to work on. So now we have the other access point 1, for example, and the MAC address. And I am defining that this access point is his name, that name, and that group, and that channels. Okay, so let's see that access point. In this case, is called AP hole principal. This access point is called AP plant floor 1. So when the access point register, they learn their name in the network. That's called this access point is called AP hole principal. This access point is called plant floor 1, and this access point is called AP plant Lautaro 1. That is the name of the branch office. So when you start an access point at the beginning, is just the prompt is just said Huawei. When you will see that the access point changes name, that's because the cap web tunnel is up. Okay, so and you will see this circle. Okay, this circle is because the access, the cap web tunnel is up, and the access points learned all the configuration from the access control. Okay. I'm going to start finishing all the things I wanted to share, because it is a lot of things, and I just wanted to show you the things that you could do in eNSP for the wireless services. So when access points are registered and they learn all the configurations, when you start, for example, a station, okay, you will see that this station is seeing a wireless LAN corporate, a wireless LAN invited for the 2.4 gigahertz channel 1, for example, and a wireless corporate and an invited for the 5 gigahertz channel 64. Okay, so for example, the other station here connected to another access point, this is seeing the same SSIDs, but with other channels, because we configure other channels in other access point. Okay, channel 6, so you want to connect, you just simply, for example, put wireless LAN, and then you will see, for example, here, for example, I want to change. If I am connected to corporate and I'm going to connect to invited, so I put the password of the password of another network. Sorry, here. So the passwords are here. So invited. Let me see. I'm going to put now. So when that is a typical issue when some, for example, I'm going to stop this device. The stations are going to stop and store very fastly. So I'm going to, excuse me, the invited. Okay. So it says connecting. Okay, this is connecting to the invited network. This is connected. So it's connected, so I can see the IP address properly for the wireless LAN for the invited guests. Okay, because I'm connecting to the invited. The invited are just VLAN 102. So for VLAN 102, I have 10, 100, 102. This is the network. So this is the IP address assigned for that VLAN. So it's okay. So another devices are connected to other SSIDs. Okay. So each SSID is obviously a different subnet mask, a different subnet and a different subnet mask, an IP default gateway, etc., etc. Okay. At this point, the last thing I'm going to show you, for example, if we are connected, yes, if we are connected to the, in this case, the guest network. For example, I'm going to start a ping for testing. This ping is here. I am testing a ping, an IP address in this the one service at the one switch. Okay, so I am going to do a continuous ping. Okay, so I am connecting in the guest, and the guest network is tunnel. So if I, for example, I put here and I'm going to show you, I'm going to start a data capture. I'm going to start Wireshark. I'm going to see the packets passing on that interface. I'm going to see the ping, yes. Okay, so for example, that's a typical packet, an ICMP ping. But what's the thing here? I can see the Ethernet frame, I can see the VLAN tag, but the VLAN tag is 100 for the AP management, for the CAP-WAP. So the ping for the from the perspective of the switch network is seeing just VLAN 100 or VLAN 100. Inside the AP packet, the UDP datagram header, the CAP-WAP header, control and provisioning of wireless access point, and inside the CAP-WAP you can see a new Ethernet frame. A new Ethernet frame with VLAN ID 102. This is the frame of the guest. So the traffic of the guest is totally encapsulated in the CAP-WAP traffic. Okay, because we define that service as a tunnel. Okay, we define it in a very manually, because the default mode is direct. Okay. So you can see all that CAP-WAP traffic encapsulated, all the user traffic encapsulated in the CAP-WAP messages. So for example, if we connect this, the same, excuse me, for example, let me see this station. I'm going to this station connected to the corporate. Excuse me. This is like an issue I told you before. And in some cases I have to stop the station and start it again in order to change the network for the station. So here is connecting to the corporate network. Now we are connected. So we're going to see that we, excuse me, let me see if I know. I have to a ping and a config. So we are in the network for the corporate. So I'm going to test a ping, okay, to the same place, the same destination. So I'm going to running a ping. I'm going to stop this ping from the other station. So just one ping is running. So now I'm going to start a new data capture. So now I am the corporate VLAN. In this VLAN, I define it as direct. So I will see the traffic of the user in a direct way. So here we have the frame, layer 2, the Ethernet frame, the Ethernet header, and now we see the VLAN tag, VLAN 100. Okay, excuse me, this is a CAP-WAP message. I'm going to select a ping here. Here. The Ethernet 2, the VLAN 101. Directly, the user of the traffic, the traffic of the users, are in a direct way. No encapsulation on CAP-WAP. So what's the purpose? The purpose of some kind of traffic being encapsulated? Well, when we have a lot of wireless LAN devices, for example, devices for cameras, security cameras, or some kind of sensors, some kind of machines in the network. We have a lot of type of networks connected to the wireless LAN. So all those devices are in maybe separate VLANs. But if we configure all those VLANs in a direct mode, you have to configure all the trunks in the wireless, in the switch network, all the trunks to pass that VLAN, the new VLAN. So if you, that VLANs of these devices define it in a tunnel mode, you only just have to worry about passing the CAPWAP VLAN, because all other traffic is encapsulated in that VLAN. So you don't have to tell the switches to know other VLAN, to run spanning tree for that VLAN, to configure ports on, the new VLANs. No, so you have to tell the switches, just learn one VLAN, the CAPWAP VLAN, because all is encapsulated in that VLAN. Okay. So
sorry, Mauricio, can you hear me?
Okay. See. Yes.
Someone told me that they couldn't see the capture from Wireshark. That I think the image got stuck at some point.
Yes. Going to show you again. Okay.
Okay.
The Wireshark. Yes, I am assuming that all that changes in the screens are automatically. Excuse me. I'm going to show you I'm going to show you the encapsulated, the first Wireshark screen, So I started a ping here. I'm going to stop this. This is a guest user. A guest user is pinging. I'm going to start the Wireshark. And now I'm going to change the okay, here. Please let me know if you can see the Wireshark screen.
Yes, so I can see it now.
Okay, so we're going to monitor the traffic that is sending that user. For example, this user is sending that ping. And I can see the Ethernet, the VLAN tag of the CAPWAP traffic, the IP header for IPv4, the header for UDP, the ports, and at the level of application here, you can see control and provisioning of wireless access points. And inside the CAPWAP traffic, you will see the frame of the user, Ethernet to 82.1q VLAN 102. So, and then the packet, and then the ICMP header, ICMP, this is ICMP. So what is the most important here? The most important is the traffic of the user is encapsulated on the CAPWAP message, on the CAPWAP payload. Okay, so it's totally encapsulated from the perspective. So from the perspective of the switch network, you will see only CAPWAP traffic. Okay, so now I'm going to do the same test for a user in the corporate VLAN, or in this case, direct mode. So I'm going to stop this. Excuse me. Oh, yes, I'm going to show you again the eNSP. Okay, eNSP. So this user is connected to corporate, okay. So I'm going to start the ping. I'm going to stop the ping from the guest, okay. And I'm going to start a ping from the corporate. Yes, now it's pinging, and I'm going to monitor again with Wireshark. And now I'm going to show you the screen of Wireshark. Now it's capturing all the packets. Then you will see the screen of Wireshark, and I will see the ping, and you will see that the ping is directly Ethernet 2 frame, that is the header just over the wire, layer 2, and then we have the VLAN ID 82.1q, of course, VLAN ID 101. So we are seeing directly the traffic of the user. We are not seeing nothing encapsulated in nothing, just the VLAN of the user, because this traffic is in direct mode. The other traffic was tunnel. So you define which service is tunnel, which service is direct, depending of the network, depending of your needs. The most typical is that for guest network, you put the wireless guest network in tunnel mode because of security issues. Okay, so I'm now I am going to return to the eNSP screen. Okay, so this is, I think, the most important features in order to see wireless LAN on eNSP, when you can define DHCP service, all the trunks, all the VLANs needed, and at the access controller, the most important is defining the wireless, the SSID profiles, the security profiles, the BAP profiles, and create the access points and the groups. Well, I put all this, when I show you the configuration, I put all this in a text, in CLI, command line interface. This is the most important thing to learn. When you want to learn this, it's important to do it at the CLI. There is also eNSP supports a graphic user interface for the access controller, but it's limited. It's limited. And when you create or you configure some things from the graphical user interface, the access controller puts their own names for the profiles. So when you create these profiles, when I show you before this, and I show you these profiles, when you do it by CLI, you define your own names. But when you do it by the CLI defines its own names. All the names in a very confusing way. So when you will see the configuration by text, you will not understand what that name means. That name is a command or not a command or just a name. You will know, you won't know that. So that's important. What you learn when you're learning, do it manually in order to understand better. Okay. I'm going to return to the, in this case, with the presentation here. Okay, so I was doing the lab demo. So the things I could do in eNSP, this way of working with the APs, the controller, forward mode, tunnel mode, well, it's unique. As I told you before, you cannot do that in any other platforms. There is no simulation platform you can learn these things in other vendors. No way. The only Huawei eNSP. There is a Huawei Enterprise Community when you where you could enter, you could create an account, you could enter, and you will see a lot of information, and you could post questions, and you will see questions people on the answers. And this is the Huawei Enterprise Community. At the Enterprise Community, you will see something like this. You will enter forum.huawei.com. It's very easy name, yes. And in this forum, you will select Enterprise Network, you will see you have sections: switches, wireless LAN, SDN, routers, network manager, access control, and you will have, if you are working with real equipment, you have your own, you run an IT administration from a company, you have issues with your equipment, you have to enter this, just switches, wireless LAN, routers, etc., security for firewalls. But if you are just learning and you have issues with eNSP, there is a section special for eNSP. So you can enter here a question that you don't know, your switch is not starting, your router does not start, etc., etc. So we very, very, very important. You have to be registered, you have to create an account, and then you put post and you create new posts. And you also will, you have the ability to search from all other posts of users and the problems they have and how they solve it. Okay, and other important, very, very important thing you could know, well, when I started to make these labs on wireless LAN, I didn't have an idea how to configure an access controller. When Huawei, the first time they put an access controller in the eNSP, I didn't have an idea how to configure. So I found a lot of information here at the Huawei site. You, for example, you enter the enterprise.huawei.com, you search on the products, enterprise networking, this is for companies, yes, for enterprise. You find wireless LAN, then from the products of the wireless LAN, you find all the products and you select, for example, access controllers. For example, this access controller, very similar to the access controller we are working on the eNSP. And for this access controller, I selected each one, any, you could select any, that it's the same. All are configured the same. So at the access controller, you go here, downloadable product documentation package. So here you can see the manuals. For example, wireless LAN controller, AC and FIT IP documentation. CHM and HDX. I prefer that you select the HDX format. Always select the HDX format, HEDX format. So here you will find the manual in an online format, the manual of this access controller. You select configuration, click configuration, because you have to always the option for the web, but it's better click configuration, and then you will have a lot of sections. For example, there is a section called wireless LAN service configuration. I'm going to select this. Well, you have all the theory, a lot of things, and you have, with all these sections, you will find configuration examples. There is the most important thing I want to show you, because Huawei has a lot of configuration examples, and if you select any of these, for example, this example, you will see that there is an example from scratch, a simple network, etc., switches, access points, the access controller, and all the configuration from scratch, from zero, okay? And explain the things. So in order to do that lab that I show you in the demo, I start with these things. I start very simple, and then I aggregated this other device, this other service. I was combining a lot of things, and I created the labs like I show you. But this source of information is very, very useful, because all of these manuals or examples are based on real equipment. This is real. This is configured for real equipment, but you can do it exactly on eNSP. So eNSP is exactly as you're configuring a real equipment. That's the most important. You're not learning another things like a toy, how to configure a toy. No, it's you are learning how to configure real equipment, because all these configurations work on eNSP and are for, and these examples are for real equipment. Okay. Well, I think you have in the presentation you have a link in order to answer some questions. I put some questions about this webinar, and you in the link you will access to that questions, and you could answer. For example, the question 1, what is the most common option used for DHCP? DHCP option 120, 43, or access points must be configured statically with AC parameters. So you can answer this question. Question 2, what is the standard protocol for managing access points from a wireless controller? LWAPP, DHCP, or CAPWAP? We mentioned obviously during the presentation. And question 3, what is the default forward mode when you create a WAP profile? Direct, tunnel, or mixed? So you can answer, and between the people who answered the question, thank you all.